Hi, folks. This is our last session of the live code week. And this time around, we'll we'll experiment with computer use in Khoj. So I'll show a little bit of how we're architecting computer use within Khoj initially. Show how Khoj is able to right now operate a computer and then maybe try and build out um, the ability to use Gemini, um, like Gemini models um, for computer use. So it may be, I'm expecting it'll be a longer session than 1 hour, given the things we're trying out. But I think it'll give folks an idea of um, kind of adding a newer feature or whatever, extending some, like adding a provider, playing with the operator tool, so that one, it like sparks your ideas on what these things can do, but also like how the thing is laid out in the like larger architecture of Khoj. So let's get started. Give me 1 second to pull up my screen. Okay. Right. So we'll start with the architecture of how the computer use or computer operator is being architected in Khoj. We have built some of the stuff and some of the stuff we have to build. So Khoj can right now use a computer. Well, I initially started with experimenting with a bunch of different variation of things. So it could use a browser. That was the initial thing I tried. Then it could control your computer. So the computer that it's running on, not the computer Khoj is running on. It could control that. And then finally, I added the ability for Khoj to be able to control its own separate computer running in a Docker container. So this is just a normal Docker container, but it has the GUI desktop packages installed as well. So not just like an Ubuntu server, but like an Ubuntu desktop in a container. It's not an Ubuntu. We're not using the GNOME desktop, but that's the idea. So I built a bunch of things out, but those are more experiments trying to figure out which models work well, which kind of environments work well, and just get a feel of how, like, the paths which will be fruitful and the paths which will not be fruitful. We may not mostly keep all these things. Right now, I've disabled a bunch of these things by default. So in code, you can go and like enable them, but by default, you can right now only use Claude. And I think you can only control the computer by default, control the Docker computer by default. So we'll get into the code in a bit, but for architectural purposes, let's zoom into this part. So the operator agent. Now this is similar to research mode, an iterative reasoner or iterative. It has an iterative loop where it does an action, sees the results, does an action, sees the results with the objective, with the user provided objective. So what we're showing here is just like this bit is just about Khoj, the operator agent. The user sends asks a request. So this is a simple /command/operator, and then ask whatever you want, similar to how you would do with research mode or any other slash command. And once you ask it, the operator agent gets invoked. And what it's doing in its operation loop, in the operator loop, is, let's forget, wait, is this the only one I have? Let's blur this visual reasoning, visual grounding bit into one blob for now. Like this is like one AI, one LLM. Let's assume that for now. What the operator agent does is just takes a screenshot of the computer it's operating. So what's the state of that right now? Decides the next action given the user's objective. So if I asked it for like, book me an Airbnb, I don't know, book me an Airbnb in Mexico City from X date to X date, right? With that objective, it looks at the screen, like what do we have right now on, what does it have right now on its own computer? And then decides an action to take. So it's like open a browser, type in this URL, whatever it is. And so screenshot and an action is the loop. So the action, once it decides the action, we apply that action on the environment. In this case, the computer, the Docker computer the code is running on. And then pass back, let the agent mostly decide like when it wants screenshot for Claude, but other folks are always passed back a screenshot of what happened. So basically, the model can choose to either take a screenshot of seeing what is up and then actually performing actions. So choosing to perform actions, and then we go in the Khoj code and apply that action on the environment. And the environment can be, as I said, either the computer, like the Docker computer that Khoj is operating, or it could be your computer, or it can be a browser. There are different environments that it could be operating. But the general principles of like type, click, drag, drop apply across most GUI environments if you're not enhancing and giving the model or the agent specific tools for specific environments, just like a mouse keyboard, if you think of it like that, right? So that's the small loop. And then after that, we extend, we plug that operator agent loop into the existing bigger loop that Khoj has, which is the research agent loop. And so now there are two iterative reasoners. One is the research agent, and the other is the operator agent. And what you do is here in this scenario is just do slash research, or like trigger research mode in whatever other ways that you can, and ask the same question from Khoj. But in this case, the research agent decides when it wants to use the operator agent, or if it wants to use the operator agent to do like multiple iterations. It could be like, if I'm talking about, again, like planning a trip to Mexico City, or like for developers, like if I'm talking about like having Khoj work on a project, work on an issue, work on a feature, help investigate something. I can tell the research agent, be like, hey, let's like, I don't know, look into the specific issue, or let's find what issue we're going to work on. And then once it's found something, like, okay, why don't you start working on this issue? You can kind of like give it multiple instructions is the idea. And the research agent will give the operator agent like subtasks to complete. Like first is the discovery process. So maybe it'll go through the GitHub issues on Khoj, look through them and decide like, hey, let me take up this specific issue. The next step will be like, okay, once I'm taking up this issue, like operator agent, go and like, I don't know, set up the local environment to build that feature or to debug that problem. And so it could be break into multiple, like from the research agent's angle, it's giving one instruction to the operator agent. The operator agent's going and completing it in multiple steps, but that's not particularly relevant to the research agent. All it cares about is getting the task assigned to the operator agent done. And once the operator agent is done with it, it'll give it the next task or give another tool a next task, right? And so they can be like multiple loops, like loops within loops. That's all. And the operator agent continues to do the same thing. It doesn't right now particularly know. Like for the operator agent's purposes, the research agent's question isn't different from the user's question. It just looks to the operator agent like someone asked it to do a task, whether it's a research agent or the user, and then it went ahead and did this task in its operator loop, right? So that's like the two-level iteration kind of loop that you can get into. And with these, like right now, I can get codes to do. So it doesn't generalize well, and I mean, I'm not sure how well it generalizes, but at least I can make codes with research mode and operator, like both of these combined, do 30-minute tasks. Where, yeah, like 30-minute long tasks, at least, which is good compared to the 5-10 minutes 5 minutes max that we would run with normal research mode. Assuming reasonably fast LLM interactions. I may not talk about, wait, so then, okay, let's just talk about these. So this is the part where I was talking about this visual reasoning and grounding model is like one LLM, whereas in the binary operator, so we call it like the monolithic operator agent, or the monolithic operator agent versus the binary operator agent. And the difference is, again, this where we break, like for the monolithic operator agent, the same LLM is able to, so why can't you use, like, one question is just like, why can't you use straight up like any vision model? So there are a bunch of vision models, why can't you use any vision model to be a computer operator? Like be plugged into a computer operator agent, right? And at least one problem is that while they can see a screenshot and then with tool use decide what next to do, they can't reliably or at all point well at an object. So if they're like, hey, I want to click on this button, when they say the XY coordinate of the button, it's not been trained on that and it doesn't do well on that. So like the smallest change that's required, like the one small minimal change that would be required is at least having these models be able to do visual grounding. And so the visual grounding bit is the part where given an image and you say like, hey, click on the refresh button, the model should be able to say the coordinates where to click looking at the image, and that coordinate should map to the actual coordinate where the refresh button lies. And so that's one bit that a plain vision model doesn't by default support. But for monolithic operator agents, they have been trained on this, so they can do both. First, look at an image and like just think through what to do next to achieve an objective, but then suggest actions with visual grounded actions where if they're saying point at X, comma Y, a specific X, comma Y, that maps better or usually to the correct point on the screen. So there are a class of LLMs which have been trained on this thing, and so they can do both visual reasoning and grounding in one go. And with those models, we can build a monolithic operator agent. But we can use, like the other model we can do, and we do, is we use a visual reasoning model. So there are a bunch of open source visual reasoning models we could use for the reasoning bit about what to do next, given the user objective and a screenshot. And what we make it do is just say in natural language, like what it wants to click, like, hey, I want to click on the refresh button, or I want to like click on the address bar to put in the URL to the Khoj GitHub issues or Airbnb. Like it it can say these in natural language, decide the next specific action, but in natural language. And then we pass it to smaller, again, open source or non-open source code, visual grounding models. So there exist open source visual grounding models. There also exist like monolithic now open source like operator models. The main one is UI TARS, but there are like UI-TARS, which is they've released the latest one, I believe, is the 1.57 billion as an open source. They have a bigger model that they have not, from what I remember, last released it yet or aren't planning to release it. But at least there are like decent reasoning and grounding models put into one. But there are like performance implications of these things as well. So basically, the two modes you can do it in with a separate vision grounding model to decide exact XY coordinates, and then a vision reasoning model in the binary operator agent scenario, and in the monolithic thing. And that's usually when you're like using Claude, OpenAI. They have specialized models for visual, like for the monolithic thing, for a monolithic computer operator. So Anthropic has just a straight up like normal models can do that. OpenAI has a specialized model, like two specialized models, which are forks of their existing like 4.0, and now they have an 0.3, but they don't expose the 0.3 to over the API. So at least right now they don't. So those are two kinds of models you can have. And this is what we say here. These are older, I guess, diagrams of Claude. 3.7 supports it. Oh, I say it here also, UI 1.5. But Claude 4 also supports, can work as a monolithic operator agent. And then the environment, as I mentioned, can be one, a browser, a computer environment. With a computer environment can be in Docker container, it could be, I don't know, VM running. Like it doesn't particularly matter what that is, as long as it supports the basic click and type mouse and keyboard actions that most UI applications support. We just pass these standardized actions into the environment, and then the environment decides like exactly how to like click or type in that specific environment. And that environment can be, so these actions we're passing standardized actions, like standardized keyboard click, mouse, mouse move, drag, whatever it is, like use a mouse, use a keyboard kind of actions in a standardized form, standardized within code form. And then those actions are passed to the environment. The environment could be, again, wherever. So it could be running on the client, so on your device, the person who's asking it, it could be controlling their computer or some computer that they have access to, or rather an environment they have access to. It could be running on the server, or it could be running on a remote machine. For the binary operator agent, it's not particularly material. All it's saying is like, hey, do this action. And then code passes that to the environment, wherever the environment lies, right? So that's the idea. We have implemented the binary operator agent. We have the monolithic operator agent. We do environment, like we support some environments, but we don't do all this, like we don't do the client part right now. Like we don't send, like we can't control, Khoj can't control a client environment, but the architecture is meant to be able to like extend to that. Remote, it can, well, it technically, whatever, it's not that much work to make it work on remote stuff or client stuff. That's the general layout of the architecture, right? So that gives you an overview of what's up. Let's see now. What are we doing? That's the general layout, and then great. And so here we have the operator module, operator package here in code. So it's under processors, there's an operator. And as I mentioned, there are a bunch of operator agents. So there's an Anthropic one. There's a base operator agent, which has like, it's a base class basically of all operator agents. Operator agent, just to remind you again, is this bit, right? This bit or this bit. So there's a base class and then a bunch of things built on top of it, Anthropic, binary, and OpenAI. Those three we have, and then we have environments. So the environment base, but from that, we built on top of that the browser environment and the computer environment. Those are these things: the browser environment and the computer environment. Right, and so yeah, so and then we have this UI task. So these were experiments. This is a lot of like experimental craft code, which we work with, and this is the main entry point into the operator environment. So this is the part where I'm saying where I've like disabled the uh, the binary operator agent. I've disabled the OpenAI operator agent because I don't want folks to like this is the to do. Like once they're useful enough, I like worry about them. But after the like this is for experimentation for now. The Anthropic model is the one I've been mostly working with to try and see how much we can extend it after doing experiments. And every once in a while, I'll shift to the others and see how they can, if they can do something better or some such, right? Okay, so this is the main entry point into the operator, and the operator environment is the main entry function to start the operator loop. So all it does is like bootstraps up an operator agent with the user query, the reasoning model, the environment type, the max iterations, previous chat history, previous trajectory, and some metadata, like a tracer. This is just a part, like, so I'll show the get diff. Wait, not this. This. This is just a small get diff, which I'm experimenting with. Like, we've moved to WebSockets as in one of the earlier live code sessions, and improve the interrupt flow. So what you want is like for long running jobs, and if you play around with these things, you'll like feel the urge mostly, I expect, to redirect or shift the direction in which code is going around doing its work. And doing its work. And to do that, to like shift the direction, you want it to be like while code is going through its research iteration within which it's doing an operator run, you want to be able to tell it like, hey, don't go there or do this thing, or why don't we like look into this other thing, right? Like in the example of asking Khoj to look at specific, like let's find an issue, GitHub issue that you can work on. We want Khoj to be able to, 1 second. We want Khoj to be able to like go through and look at, so let me just show how this works firstly so that people have an idea of. One second, let me also start from scratch. Where is this? I'm just going to clear the, where is this connect server? Oh, sorry. Okay. So let me just start up the computer first. So this is how you start it up. I'm just in the Khoj root folder. Wait, not this. And I want to do the computer use. So I just want to like Docker compose up the computer, the Docker container for the computer. Most of these errors shouldn't be affecting it's still starting up. Okay. Right. So this is how the computer looks. I just RDP'd into it. Like you can like it's just a normal computer. You can kind of click and open things. There's a folder. There's a file system. There's terminal. There's a browser. It's just LXD or something. I don't remember exactly the desktop environment that it's. I set it up with, but basically standard, lightweight. desktop manager that we have for Code, this computer. And then this is the question we wanted to ask. And so usually here we have like this on slash operator just to show how that works. I don't care. That's fine. Okay, let's go. And so it's like it starts to launch its computer. And then you'll see the train of thought here, hopefully. Right. And so this is the screen it's seeing. The train of thought looks like a video. So you'll see a video stream. Yeah. So it's like a video stream happening of what Khoj is doing. And in the bottom, it's thinking. Now we can improve a bunch of like the UX stuff around how the train of thought is being shown. It's a little not very visible, but you can see it thinking, being like it's trying to open a browser. It's taking a screenshot. And you can kind of go back and like see what it did earlier, right? Like you can see its thoughts as it's going through the work it's doing. And then you'll see it hopefully like get to checking the weather. This is of course much slower than you like non-operator mode would just get the answer much faster, but there's just an example of how Khoj is able to operate its computer to do some of the work. Some of the work like can be done much faster with specialized tools, of course, but this is a general purpose agent which can do the other things, even if slower, but a lot more. So it's a much more versatile tool, the computer tool, than the specialized tools we build. And so there will be a little bit of interplay between like where do we build specialized tools and then where do we let it do a general purpose, use a general purpose tool like operator. But the idea is like we build specialized tools for like standard use cases. But if it can't do like the MCP client where you could extend Khoj, here there's a general tool which people can fall back to, or the Khoj agent can fall back to, if there isn't a specialized tool available to it to do computer work. Because yeah. And so yeah, like it's going ahead and not been following along, but yeah, it's searching for the weather in Nairobi, gets the weather, and hopefully it'll report back with what it is in a bit. Great. So this, yeah, that's the other thing. Like the examples would be slower, just because, like the testing loops are slower here, just because you, like each iteration takes a while. And so here, like it's kind of reporting what it's seen up, and then the main guy will, like the final responder here will use that report to give you the answer, right? Great. So this is an example of how Khoj is able to like use a computer, and this is what you'd see as a user when Khoj is operating its computer. We've maintained a train of thought so that we can see when Khoj did what, jump back, jump up, or be live, like live following or live streaming. It's work. Like we are live streaming our work right now. Cool. So I guess we've shown the architecture, we've given an example of what Khoj can do, and jumping back here, we are at right. So this portion was just like if I want to redirect it, I'm trying to get it to work, but I'm not sure whether it'll work or not for now. We'll let this bit be. Apart from that, there isn't much. This Docker Compose up is just kind of building from, like this is just the Khoj computer, but it's building it from source. There's no update to computer to Docker. So this is just what you'd get by default, the default computer you get. That's it in our, yeah, this is again like same with the interrupts, trying to improve the interrupts, and then again the commits are, this is from our last session. Uh, what is this about? Oh, I see. Yeah. So like last session, we like built out the MCP tool, like allowing Code server to connect to any MCP server, and there was these errors we were hitting in saving the conversation and stuff. So I just looked into that and cleaned that out. So that works fine for now, and I verified and fixed up the STDIO interaction, so you could interact with an MCP server um, over HTTP or STDIO, either or, and both those work. And Code is able to um, turn these kind of research iterations into valid schemas that are required by code. Okay, so that is the lay of the land, and now we can get into. I'm gonna do light mode because in the daylight it's easier. I feel like to read, but what were we doing here was right. So okay, so this is the job now. Like yeah, so for the feature, I think I already mentioned this, but what we're going to try and do is add. So Gemini doesn't specifically, or maybe they claim now, I'm not sure, but they don't specifically say that they can, like, hey, our model does computer use, unlike Claude, which like Anthropic models straight up have a documentation page for computer use, but they have like the Gemini models have like basically they seem like they can click like do grounded actions based on this Google collab, which I found from, again, this is I think an official Google collab, yeah, Google Gemini collab notebook, where it can like point at things and click. So what we're going to try and do is add Gemini as a monolithic operator agent. So this Google Gemini thing, like basically this part we don't have, and we'll try and add this. So we have OpenAI operator, we have Anthropic, we don't have this again, UITars. We have a way, like, so actually we do have a way, any OpenAI compatible, any model served through an OpenAI compatible API can technically be used again. So that's how we do UITars. But again, all those were experimental. But Google Gemini, we have nothing. So what we do is in this file, this is what we see here, similar to how we have an operator agent Anthropic, or operator agent OpenAI, or operator agent binary, and operator agent Gemini. Cool. Let's go again. It's been 35 minutes now, and we haven't started on the work. So this would, I'm expecting, be a longer session, just FYI. But what we're doing is, wait, let me look at the. Yeah, so we'll tell Cline with Gemini 2.5 Pro to what was it? So create an operator agent for that use Gemini model is similar to how we've done it for this, similar to how operator agent Anthropic. So that's There's no ability of Anthropic. But we need, so because the Gemini models don't have um a computer use tool, so let me just show you that. Anthropic. Yeah, so this is exactly it. So there's a get tools. And this is again like using the function calling paradigm that if folks already know than that, or like what we've seen already as used in the first two sessions. There's a bunch of tools. This was built before the function calling stuff we've done. So while we could like um, collate that work, some of the work that we've done in these into the same form, like the same standardized tool calling form for now, that doesn't, excuse me, and that doesn't happen. But this is just like a list of dictionaries of all the tools, their name, the type. Oh, right here. Like if, wait, why? Oh, yeah, you get the name type is fine, but isn't that like a what you expect is like the input, the standard make default tool. Oh, these are server-side tools. So these are server-side tools for Anthropic. The Anthropic API provides. So the like tools being provided at multiple layers. One is the API providers provide their tools, server-side tools. The other is Khoj can provide its own server-side tools. And then the final is the user could provide. So and there could be like multiple folks in the middle. So it's gonna get interesting if like there are like multiple layers in the stack providing tools. Um, like is it gonna be more than three? I'm not sure, but at least right now we are at 2 to 3, depending on who's defining the tool, the user, like the AI agent application or the AI model provider or the AI model API. But basically, these tools are provided by the Anthropic model provider, like the Anthropic API, and so they're defined in a slightly different way. But where were we at? Right here. But for non-standard tools, non-AI API provided tools, you'd define them in the standard form of like name, description, and input schema that we've done for the back and go to button if you're using a browser. Right. So those are server-side tools, or like the AI model provider tools, which Gemini doesn't have. So what we need is there is someone, there's operator agent, the grounding agent, yeah. Oh yeah, this guy. The grounding, yeah, so this guy has all these tools with name, description, and parameters. So again, this is not in standard form, but effectively it's like the input schema, right? Name, description, and name, description, and the schema. So that's what we want to tell it, but we need to define all the tools similar to, oh wait, this guy doesn't support that, so we have to be like similar to get, like we can't specify functions, like refer to functions directly to Cline or Claude Code, but we can do it with Copilot Chat. So we just have to do it in this form, but we need to define all the computer tools in hash grounding. And maybe just and in and maybe what was the other, there's operator action, which is where we keep the standard action. Just good. This is where we have the, as I said, like the actions are formatted into a standardized form. on the code side. And so this is what we mean. These are structured classes for each action, which inherit mostly from the base action, and they have a type. And then apart from that, they have their specific forms for click action, double click, triple click, scroll action, key press, type action, wait action, whatever action, right? So, and maybe. But in Gemini, schema, function calling, tool use, schema, look at op, no, operator actions for the complete list of tools to support. Okay, so those are two things. One, we want to implement a monolithic operator agent for Gemini, similar to how we built it for operator agent Anthropic. So we told it that. And then we told it like, hey, but you don't have like the operator agent Anthropic server-side tools for computer use. So instead, see how the tools are defined in this grounding agent, but form them in the Gemini function calling tools use schema, assuming Gemini 2.5 Pro already knows what that looks like. And then other is look at the operator actions for the complete list of tools, or not tools, computer use tools to support. Do we need to tell it anything else? No, for now, let's tell it this. Then we will get into the Google Colab and try and understand specifically how the Gemini models return these like bounding boxes or like click action things, and if we can trigger it. But right now, I just wanted to be like, hey, just copy. Basically, like, it's a copy paste, like an intelligent copy paste of great. It's an intelligent copy paste, like what we would manually do from like the way I would do it is like copy the operator agent Anthropic, modify it into a form which works with Gemini. This is a like this agent mode is allowing us to do a more intelligent copy paste where we like, hey, copy from here and copy from here and copy from here and like make it into a form that works and makes sense. So I just allow it to edit. Let's look at what it's doing. Oh, it's an editing grounding agent. Oh, well. Um, hmm. Uh, okay. Let's see. It added some things which were Anthropic specific. Maybe. Okay, let's just. There's a name. description, parameters, type object. Is this different from the grounding agents thing? Because of no, it's not. It will tell it if it's like not in the correct format later. Let's just think. So that's the reasoning is fine. I'm trying to like call the model and um, parse its response. Call the Gemini API and parse its response, being aware of how Gemini does it. At least that's what it's saying it'll do. Let's see how it actually does it. Function declarations. Yeah, I think that's that they do that. Yeah, function declaration tool. This is I think the way Gemini does. At least some part of it of the tool definition looks like that. Okay, so it's added a format necessary API, add action results. This is a way where code the operator agent gets to know about the results of the action that it wanted to take. So the tool call and the tool result bit. This is where we get instructions, get tools in the act bit. That's correct. This is a compaction part where, like, oh yeah, these things, as I said, like it can do a half an hour long job, but again, context windows are still a real thing. And so once it starts to hit message limits, we compact the operator's trajectory so that it can continue doing its work, even if the fidelity of its past actions have been compressed. And then here it parses the actions, so the tool name into the standardized actions that Khoj supports, which is what we wanted to do. I am not sure whether it has all the actions, but it does have like clicks, go to back, sure, but those are for browser. Hopefully it's just limited for browser, but and then key press, type, screenshot, drag mouse things, and then editor specific things, or terminal specific things, which I'll talk about later, because we handle them a little bit more in a special form. This is just for, I think, somewhere in the middle, like the model's being told, or somewhere like the user's being told, like how this thing is supposed to, like what the action's been taken. So that's what that's about. And then the instructions are for the browser environment versus the computer environment. The model's told some like different things. We could try this. Yeah, so as I was saying, it's like a more intelligent copy paste, but you need it to be guided a bit, I guess. And then let's just open this thing up, prepare for how this, right? So there's just a point and a label in this part. So we could just turn that into like point and instruction for like mouse click things. I'm not sure, but basically this is just a prompt, a user prompt being given to the model that are specific. like configuration changes, at least here. Yeah, it continues to do that. I'm not sure if this image format is, does it say it's for something here? It's at like for rendering or something, but is it for rendering actually, or is it for like, because it's being passed in a model? Point. Right. So okay, they're also giving like instructions in that label part. It's fine. Oh, there's no tool call at all. They just like straight up telling the model the JSON format, which and the other part that's unclear is like the the chair is big enough, right? Here it can click on that. It can click on here, it could click on here, and it'll still be the chair. It's unclear whether it can click at precise things. Well enough. Again, we'll see that because these are like big objects which is pointing to, which is one thing, but that we need. Well, here it pointed at a specific thing. So, but anyway. Okay, we don't care about predicting 3D bounding boxes. Wait, where are we here? In this analyzing 3D scenes. Don't care about that right now. Pointing to items using Gemini. This is all we care about. Here it seems like all they're doing is like just straight up telling it to be. Let's move away from here. Yeah, just a point, like point and then label. So I guess we could just, yeah, actually let's just see like how it'll work. Like there's no specific configs. Okay, where are we at? Wait, what's the difference? Wait, we can just, what's the problem with this? Oh, it's not called. We can just use, like we can just do this for it. Where is this function called? Okay, so that we will fix and then send AI dot, what was time? Types dot tool. Wait, can we just function call? Yeah, it's just here. Never mind, I've fixed up problematic lines in the operator agent. Gemini.py continue with working on completing the feature. Okay, it imports this. That's good. Model type is operator model. Wait, what is this? Is operator model we anyway set? Oh, it's just pulled that out to a variable. Fine. And then for Google, it's made this thing. Where is it checked here? It's checked for. Okay, great. We can. It isn't it 2.5? Yeah, 2.5. That's great. Cool. Right. So once it has this based on our reading of the Google Colab, it seems um like maybe in the system instruction we can tell it. We've told let's just see if the integration works when the model says where to click. With tool call, is it able to is saying it at the right place, right? Like we'll start with that. Okay, so I successfully added the Gemini operator agent. This involves creating a new Gemini operator agent class, defining computer operation tools, and integrating a new agent into the operator dispatch logic. You can now okay, this is its claim. Let us look at what it's I should have separated my changes. What have I done? I had done this bit, this bit, and this bit. And then this bit. Oh, and this bit as well, the interrupt query part. Okay, I don't need this. And then we'll assume somehow that this makes sense. And just commit it. Improve interrupt or pass interrupt down to operator. Guide trajectory. For trajectory. If there are issues like this, patch that commit, but and this part is just temporary local stuff, so and mostly disconnected. So we fold that bit. Okay, but this is what the Cline Cline with Gemini 2.5 Pro has done, which is one. Yeah, one is just adding it to this. The other is creating this operator agent. Right? Okay, so let's look at this. It's wrapping it in function declaration. Let's just verify. So here we do wrap it in function declaration, and then we do a name description parameters with the schema. This is the standardized dictionary schema that we like the standardized tool call uses, but the main parts are like name description, parameters is the name, and it's put in a function declaration for Gemini tools. So that's similar to, I'm guessing, this where the tools have name description parameters. Okay, so that is fine. The tools are in the format that we are expecting. These are the instructions, which are similar to, I think, what we gave. The anthropic models, these are the initial instructions. We will not mess with that. What is this Gemini chat? Oh, this. Wait, why does it not? Okay, there's some. Uh, First thing is I changed for some reason that didn't work out, or it overwrote it from Google.Gene types, I think, yeah. Import function called, yeah. I don't know why like the threads quickly are not coming up here, but maybe because I said that I fixed up that stuff, it didn't try and look into it again, but let me just tell it to be like, wait, where does it get Gemini? Um, hmm. It tries to get the text response and then the tool call. There isn't any tool call. Oh man, this is like there aren't any functions to do. Like there aren't any functions for this. Um, and agent message doesn't take. Um, mm, we would want similar to how we did it for the other the or some that we pass in the raw response. What do we call model two here? Use the send message to model. Or implement it in the operator agent. Gemini directly and update. What was it called? Agent message. Agent message to be able to track raw responses. used in place of in place of agent message.content. Okay, I'm telling it a bunch of things. Let's see what it does. But basically, we track the raw response. We track the raw response for tool calls and then put that back in for the next part of the multi-part query, so that it follows the format, the API specific format, and we're not kind of going between the standardized format and having to have the standardized format have all the stuff that each separate AI model API wants or requires. We don't want a tool role. This is just what the assistant said, and then yeah, we don't. Wait, the content already supports a list of nothing else. So we just put it in that. Oh, but no, we want the raw response. Just made the edits for the model, for the agent to kind of here you see what the agent suggested and then what the user edited. It so kind of gives the model a bit of context. I should have staged its previous changes. It's okay. Let's see. Not doing it. This form at fixed frame. In the act, it calls the models, it calls the model and then tries to put it in our standardized tool call format. Let's just look at util ourselves. Wait, where were we before? Maybe I didn't say the right things to it, but basically, model.generate content, then we get the raw content, and we do create tool calls here. What do we do with the raw content? Pass in the response with thought. And this guy is pass tools through the model keyword arguments. So we can pass those tools through here. We can pass system prompt, we can pass model name directly. Now let me see where we're at here. In the call model, there's a bunch of agent messages, the model name, the system prompt, and the tools. So this is exactly what we need. But instead here, can't we just, I wonder, call, what was it? Well, Gemini completion with back off maybe, but can we call Gemini send message to models? Yeah, which isn't doing much more. It's also taking messages, model tools, and I guess those are the main things we want to provide. So we could just call Gemini send message to model, hopefully. Gemini send, wait, what's it called? Yeah. To model and then pass it. Yeah. Messages equal messages, API. Wait, sure. System prompt is correct. That's the main thing. Then does it take a chat model or model name? Not typed. And then this is model name. It takes a model name. Then where's the API keys passed separately? Okay. So we do this, and then we do model equal to model dot model. Wait, what is this model? It's a chat model. Model name, yeah. Yeah, okay. So model name API key can be passed later. The main parts are tools. Sure, max tokens. Does it take it? Wait, let's import this. Okay, so messages, API key model, that's fine. Base URL. Okay, API base URL. Okay, so let's see. Wanted to think deeply, I think. And then tracer. Okay, we don't have it. Okay, sure. Okay, we have a tracer here. Tool response schema and stuff. Not material, I think mostly when we have tools, we do this, else we do this other stuff. So that's a material. So we have all this stuff, and we get response. Like we need to update a few more things, but we don't need any of this. And we don't need to do any of this. We can just return response. We don't need this. Now we can do one other step, which is do this. It is not required here. That's fine. And we will instead convert each of the 18 messages into chat. What is it called? Chat message format. This is the format, and so it has a role and type and then maybe content somewhere. Yeah, yeah. Wait. Okay, so role type. Wait, type isn't required because that's chat. Role and content are the main things. Where would be here? And so we do chat message. And then let's import it from LangChain. Okay, so we have chat message here, content, and then these are coming from. Oh, I see. We need to. Do we have a format message for API? Yeah, this thing. Oh, it is already doing it. What is this doing again? These formatted messages are a list of. Hmm. Oh, and it does this thing. Yeah. So if it's oh, maybe then it's fine. We just role. Wait, no, we need to shift the role. Into like one, like the other role need to be shifted back into the kind of model and assistant form that model and user form that the Gemini API supports. But this is taking agent messages, converting it into list of content, which is like it's kind of skipping the middle step. Format messages for API messages. Oh, this is used by the base. by the base class. We just called by the base class, and then what do we do after that? Wait, I'm not sure what it's going to save or reject. So I'm going to I could save with my changes. One second. Call model is passed a bunch of agent messages. Okay, which is like act calls this directly, so this is fine, and then so we can format it with, I wonder. Let's just see how the Anthropic model is doing it. Call model, it's called an act, that's fine. Then here it takes agent messages. Oh, it does format messages for API here. Right, so we could, yeah, okay, we could still do this. Let's do that. So then if it's just called by that, it's just called by the, like the agent itself. Where were we? Format API. It wasn't there. Yeah, okay, format message for API. Here, instead of content format, if we can, yeah, and then just pass it down and that will do whatever we need. So here are we doing it? And let's see what Anthropic is doing. Right, this environment stuff, right, is what we want. If environment, then it's user, otherwise it's message role. Makes sense. We'll do that here. If it's doing this, if message dot role. Well, that's fine. Wait, I want to paste my. Oops, not this. Let's do 2 steps. Oh yeah, we can get this instead. In assistant or environment. Then we do this. Parts is equal to raw content, and then formatted messages is this list, but we want it to be a list of sat message with content part, right, and this is right, except for the think the sequence. Why did it do this? It's a list or a string, it doesn't matter because this takes a list or a string, right? String or a list, and this can be string, or it can be a list, right? So it doesn't matter. Actually, then we don't even need this. If else sequence, we can just do the else. Okay, so messages are now formatted in a list of, yeah, chat message, the type we expect. So okay, so this is what, and then all of them usually have two, except for the binary. Other split pane is a little annoying, but for now we just have to deal with it, and then we do something similar to this in call model. Where is call model? Call model is, this is what we do here. Pass it messages. Oops. What just happened? Oh, it just jumped down. Okay, so now what we do is take a bunch of agent messages, turn them into chat messages form, and then pass it to this with system prompt and stuff being what they are. I guess that's all we need to do. And then let's just copy it because that I don't want it. No, we don't need any of this. Okay. It was another miss. Non-required import. Okay, copy and then let them save. So I'm just going to paste it into Scratch here. So it's not lying around in my clipboard. Interesting. Should check this and then move on. I don't know why it's gone on some side trajectory. But for our purposes, what is this? To response is added to content. This wants the list of parts. Okay, let's just wait. How much time we've spent? An hour and a half already now. Where are we at? And we have not started testing this, so let's start testing this flow. We have an act where under the cell.compress, so we have not implemented. That's fine. Don't need to worry about that right now. There's a bunch of tool calls which go into what do we do with this? It just matches them to code. And response. Yeah, so this here we map them into specific actions, but put into action results. And then pass that agent act result with the action results, the actions, and the rendered responses for the model. And now we should, let's see, start this up, see what's up with any errors during start. And then the next step would be to switch to the Gemini, like use the Gemini model and then ask it an operator question, see if this first flow gets triggered from the operator entry point. And then second, if it does get triggered, is it able to do any of the work in terms of calling the tools? Like first, does it even wiring up? We've done work. And then next step would be to see if the Gemini models themselves, without much tuning, are able to, okay, so this started up fine. That's good. We will now switch to, yeah, for now we'll just switch to 2.5 Flash because we want to test not the model capabilities, but rather the whether the wiring works out, and Gemini 2.5 Flash should be faster. Okay, we have to put breakpoints, which we've forgotten to do here, just to see, or just to see if we get triggered into the sequence. Okay. First error is of our own creation. Send message to model takes nothing like a system prompt. Oh, I see. Maybe the messages have, yeah, they pull out the system prompt. So this is how the system prompt is passed to it, which is what we'll do then. So right. So what we do here is system prompt system message equal to maybe just a chat message that we append here, and then system prompt becomes nothing. Okay. So that is just verifying we have tools as an argument, model keyword arguments are, oh, we don't have max tokens. So okay, let's remove that. And temperature. Well, let these guys pass whatever they want to. Oh, they're not passing it, so it's not material. Wait, call model maybe well no. Wait, this guy takes system prompt, yeah. Take system prompt to message model system prompt tools. Message model system prompt tools. So that's fine. And then convert the system prompt to a system message of chat message model type and just append it so that the Gemini send message model wrapper or send, yeah, will pull the system prompt out when it's sending it to the Gemini API. But we have messages, we have tools, we have model, we have API key, we have API base URL, we have deep thought, and we have tracer. Okay, cool. So let's start again now. Let's see. Once we fixed up the arguments being, or have we fixed up all the arguments being passed to the Gemini send message to model function, which will call the Gemini API on our behalf. Oh, that's another thing. Response is a response with thought, which does have a if response dot raw content, I guess. Wait, here we when Gemini completion with back off returns tool calls. I want to see how it returns it. response of function calls, pulls out function calls, response text is dumped into response text, which I think is put into text. And then raw content is SH3. Yeah, so then we have this, and these tool calls are it's already building the tool call, so we just need to JSON.loads, I guess, from text. Maybe this is thought, and I'm going to put a type of thought string, so that's fine. Cool, and then the text we pull out tool calls to JSON.loads response text. Done. So we have a JSON.dumps here for the function calls. It's put in response text and then passed back in response with thought text by Gemini completion with backoff, which is called by Gemini send message to model. And we pull that out here with from response to text. And these should be tool calls now. So list of tool calls. So now that we have tool calls, let me do the rest of it with it. And then we pass in raw content and content. So content is just what the model's thinking. And then the raw content is the actual tool call that the model requested, which we'll pass back when we do the format message for API. When a raw content exists, we use that. Otherwise, we use response content. When there's a tool call, then this will exist, is at least the expectation, right? Okay. Right, so model type is Google, which then should trigger this, which we already saw it go in here. Maybe we should put a breakpoint. Well, let's be optimistic and put a breakpoint there after a response has been got. Okay, let's see where we're at. Dictionary object has no attribute. Passing a dictionary somewhere. I see model keyword arguments as a tool, like a dictionary of things rather than a dictionary of tools rather than or a list of dictionaries rather than a list of tool calls. So where were we? Here. Wait, firstly this doesn't even seem right. The raw response, right? It is raw. This message is of type agent message. So we are just passing it back in contents as is. Okay, that's one thing, but that's a side point. We call it here. But tools are, wait, it's supposed to be list of dictionary, but what are they? Tools are get tools. Oh, they are list of dictionary. Okay. So Gemini completion will back off. Not this. Like that's I don't know the type, but just this. We have not typed it. Okay, let's just jump to variables. Here, to Gemini tools. This possible list of tool definitions. I see. So these aren't a list of dictionaries, they're actually a list of tool definitions. So if you were to use this get tools, um, okay, in this, we'll keep it as a dictionary in like for the main operator Gemini agent, but here, like we formatted tools, we messages we formatted for the Gemini send message model tool. Tool definitions. Um, and then it's tool definition. And then we pass it to, and then let's just see what the get tools does. Get tools is bunch of tools. Like there is a function declaration thing, which yeah, it's in. We don't need to do this actually because the model will do it. Like the function will do it for us. So yeah, we can just pass back the tool straight up. List of dictionaries, who's it used by? List of dictionaries, this tool passed here and used by this. And that's it. Okay, great. So wait, we could also just okay, let's not. So we'll just keep it in this format because that's what the operator agent formats use in this dictionary format. And then here instead we'll do tool definition, which is expects a name description schema, which name description schema. This is not gonna work. Schema. At this point, which is effectively creating two definitions. So we can reconsider that in a bit. That idea that I just said, because now it's not in Gemini specific format, it's in. Oh man, why am I doing it like this? Parameters, parameters, because there are quite a few of them into schema. Actually, let's be even more specific. Then find out. Let's replace all gotten this defined. Okay, so name description schema format is what this is also following. Wait, isn't it? Result properties, yeah. No, okay, that's within it. Yeah, all of them are following this format, and then name description schema is then what this guy expects. So we can just do this. Let's just go and run this, see what's up. So we just reformatted the tools in a form that is acceptable by Gemini send message model, which is a function that already exists in Khoj that we're reusing to call the Gemini API, and that expects like tools we pass in the standardized tool definition format that Khoj is using, rather than like the model specific form, and then the Gemini send message model eventually converts the standardized tool definition into the Gemini model specific form. So the caller doesn't have to worry about model specific formats. And then let's go and see what's up. Okay, so we got a response. That's great. Okay, it's interesting. It's trying to. So again, if you're not, what the hell? I thought could do this. Anyway, we're not right now tuning the model. We're just testing if the flow works, but it wants to use a terminal to search for DuckDuckGo weather in Seattle, which isn't going to work, but we are going to see if at least the iteration loop works, right? And so that didn't work because of the render response. So here in the render response, it's expecting a list of tool calls. Oh, we didn't check that. Let's go again and try. Delete this. I want to see how, like, I want to step through that part. Okay. Response text is a list of dictionaries, but in string form. So let's, oh, I see. Yeah, we just use JSON loads here. That's the problem, but let's see if that loads. Yeah, it gives us a dictionary now. What we want is actually a list of tool calls, which contain name, args, and ID, which is what this contains, right? Great. So we just need to do tool call star star. Oh wait, yeah, wait, what it did. This and have to be right. So for each item, we want to wrap it in tool call. So we get the list of tool calls, and now we'll get the render response. Wait, why is it called function call? Oh, I mean, the type name mismatch, but otherwise, seems like Google has a function call thing, which is almost exactly what we have. Not almost, it's actually exactly what we have. So they also like basically their format's exactly what we have. Yeah, I think because we just do some, we don't change too much of the schema that we pass to the function calling. when we're doing function calling with Gemini models. So Python has soft typing, so it's not gonna complain mostly. Right now during runtime, but MyPy will complain later, which we can deal with. Great. So we have a bunch of tool calls with name and ID. And then we added two messages, assistance message, which contains content. And then what is it? We had raw response rate. This is the raw response where it has made a tool function call. Put blah 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 in it. Okay. So let's see if the render response works. That worked. And then let's see if it yeah, if it goes here, makes the action. I think the rest of it should ideally be fine. But anyway, like let's just step through it and see what's up. Okay, so we're seeing the operator launch happen, but now the second sequence failed, which is compile response wants something. What is its problem again? Oh, compile response is used by someone else. The base model. Uses this during summarize step and commit trace. Yeah, the base during the where is it? Yeah, here is expecting message dot content. No, that's not the problem. It requires one. Oh, just agent message now require require agent message this. Okay, so what is the thing here? Compile response thing is missing one argument. But then the stack trace is showing we go all the way to operator agent. Oh, the compile response here being called. Let's see. Let's see. Tool calls. This guy is expecting this thing called tool calls. Whereas the standard definition does not. And then why it does this is because okay, this we don't particularly care about. So we'll just for now assume response content is good enough. Or actually just tool or this. Just made it optional for now. Message that content contains. Okay, let's just go with this for now. The compile response bit is not that I think relevant, isn't it? Because it's going in the. It's just being used by the prompt tracer. So we have a prompt tracing tool within Khoj, which allows you to kind of look at what query, like what raw query and response form the model is following. So you can look at it and kind of understand what the model is actually seeing and then what it's responding with. Just used by that. We can fix that up later with the tool calls and things like what I was required to show the prompt trace. But for now, we're not going to worry about that. Maybe adding the tool calls in the form that Gemini said is the right form, but how to pass it is TBD. So it does the first step. Okay, now it again fails at after the wait, let's jump here. Oh, I just put a breakpoint here just to see what's up. Oh, whoops. This was a normal search. Okay, and then we'll see. Compiled response is a list of. Oh, what is this? Okay, so I will instead just. I think this is like trying to like remove nuns or something, but we don't need all that. Um, like the filter function is a takes a lambda as the first argument by which to filter the second argument. I'm not sure what the filter none would do. Yeah. Hmm. But there must be some default. Semantics. Or maybe some logical thing that we haven't thought through about when the lambda's none, what happens. Okay, this is fine, this is fine, this is fine. Let's do this. Oh, still didn't like what I did. It should work right. That's just string. Who's calling this thing? Oh, it's within. Okay, whatever. List found. Maybe I'm not just reading it well. I didn't notice the. Oh. Because it's been called with a base. I'm getting confused, but let's see. There's a content. This can be a list. I see. Content. This can be a list or a string. That makes sense. Given the type. So what we want here is not this. We want is if is instance list, then this is bulleted list, else response content is wait, not response content compile response list. I see this is what I was trying to do. Let's not do that. And then I'm just wondering, should I keep this around? Keep it around for now, and then just make this. I see. Yeah, this we can do. And don't need to worry about that. And so then we just becomes simpler. Yeah, else what it's saying. Oops. Else response content, now compile response to list. What is it? Then it's a list. Otherwise it's a string, whatever. And then we can add the tool calls and we can join it. I think filter none just it'll match against none, so it'll remove all the nuns from it, which may be useful. Filter none. And then continue with that. The soft typing, I mean, at least having some typing in Python is good. Allows us to kind of reason much faster while not getting bogged down with types, but there are trade-offs. We should have shifted this out to a tool call. And this out to a tool call. Do it for now. The next one. Yeah, and our function call is not used. Where is part used? Add action. Oh, this would also come problematic, isn't it? Add action results. Yeah, we don't even want this. And dictionary is sufficient. And what is each action result? It's a list of dictionaries. I'm not sure whether this will work. Tool responses is a list. And do we, okay, I'll just for now, where is this is error pattern being used? I've seen it. Oh, I see action results is this type tool call. So there will be a name in there. Content is error. And this is what so this is what it'll contain. And then when we build, I see add action results updates this part. Okay, let's just this part wouldn't have worked earlier because that part usage, I think. Yeah. Basically, we don't want to use directly any Google API, Google package things because we're calling Gemini send message to model. That's handling, that's our like abstraction layer into that. So I've removed. But the Cline model had initially tried to build it out with um, um, by calling the Gemini API directly. Which is why it had used the like Gemini package specific, like the Gemini API specific package types, which we don't need to use anymore. Oh man, it still didn't like. Let's try again. Expected string but got dictionary. Oh, instead of list, it can be a dictionary. So first we should I just let's see. When the model is seeing a dictionary, but I mean the fixes. Not involved, but just wondering why that's happening. Okay, so here it's a list of strings. So that's fine. This is fine. Oh yeah, here now we have a Oh, I see. The list contains a dictionary of with tool call and content in it. Yeah, so we maybe need to. Fit in that case, we could just do this. What all does it have? Tool call content error. Oh, I see the what we had. This is the result. Um, of like DuckDuckGo not command not found. Um, we could just do JSON.dumps here and then move on. So if it's a string, like a list of strings, then that would work out, and then we don't check it. No, it's not this. Jeez, item for item and yeah. So now I think we should be good. Each dictionary is like turned into a string. each dictionary or like whatever. If the item is of type string, then it's fine. Otherwise, it's turned into a string, and then we don't. This type is wrong. Um. Okay, let's go. Let's go. We are at 2 hour and 10 minute mark. We should hopefully get the model, like interactions with the Gemini model going. That's what I'm hoping for. Maybe it'll take, I don't know, 20, 30 minutes more. And then we can, okay, so, yeah. And now it's a, wait, what is this? Okay, this is what, oh, the initial thing was a user's request. The second thing was the model's thought. And then third is a string, a list of strings with the model's tool call request. Again, okay, so now it's failed at a different part. Where if item of type um the tool call request don't have a type is had a type rate is error we saw somewhere. Type, yeah. And we should put a breakpoint here just to see format messages for Gemini. Like where the type thing is not there, why it's not there. But I was saying like I'm hoping we can get the provider, the Gemini provider, the Gemini operator agent like functioning in this loop. So the what we're at right now. If we can get that done in like 20 minutes or so, then we can try and do a little bit of optimization for it. Otherwise, at least getting that working would be a good point to end at. I don't think we need stuff here anymore. Okay, now message content. Oh, this is a raw response. Hmm. Oh, wait, let's see where we messages. Hmm. So what we need to do is instead pass in the content, not the whole raw response. Wait, what is even which source memory? Right, this function call bit. Like we just need to pass this with message type. Set to tool call. Maybe not even that. We just need to set message type to tool call because then it'll pass setting anything. Yeah, maybe we need to do that instead. Okay, so let's stop this. Let's go to operator agent Gemini and then raw response. We act, we get a raw response from a model which contains the response with thought, which has a raw content, which has a tool call in it. All right, what we need to do, where was it? Here is additional keywords. Tool message type. Type equal to tool call. Let's put them on separate lines. Most readable. But what we want is yes, this. And then why is this thing hanging out? Okay. Right. Let me add this. So now the message type is of tool call, so it will not do anything to the raw content or to the wait. We need to then when we're doing formatting, where is it call model? Format message for API. The assistant request that we need to. Oh yeah, here we need to add this, but for only tool calls. How do we know when it's a tool call? It's when it's a message by the assistant. The assistant. No. Like the assistant can respond with like text as well, so not all. Oh yeah, but if it has a raw response, then I think it's a tool call. We'll verify that bit. And we didn't need this. All right, here we need to add that, and then we added it somewhere else where there was an agent message, which actually important, like doesn't support additional keyword arguments. Okay, so we put an agent message, and then with raw content, it's the only place we put it, and this is when the model responds. And the model responds with raw content set at, yeah, I think only when there's a tool call, which I can verify here. In the Gemini completion with backoff function, which is eventually calling the Gemini API, we populate the raw content in the response with thought, and raw content contains uh, mm, like this one's dumping it all the time. Oh, content at parts. And then this one calls what again? If it contains function calls, we want to just do raw content when. Do you want to just do raw content when there's function calls? And not always. Um, is this the only place raw content? Oh yeah, we need to. So raw content is a list. Um, but it's set to the model tool call only when um there is a function call. Otherwise, it's an empty list. We want to pass like when the model responds with some text. We could pass that as well. Model responses are only things which are passed back as is. Actually, yeah, that would work as well. Like we don't care about formatting the model's responses themselves. We just care about our the Khoj part of the interaction, not the user part of the interaction. Um, so while they may not be like they could be tool calls or they could be text replies, we just kind of pass that back to the model as is. Okay, yeah, I think it'll work. Let's see if it does or not. Mm, okay. Okay, we're here. And here we should see. Yeah, so we're only seeing it for tool result, which I mean ideally would mm, let's see what happens. Oh, okay, so messages like the tool results are like a list of dictionaries rather than the dictionary itself. What we would, like what this is expecting it to be is just a dictionary. So otherwise it's dropping that, which is not good. So we should here. Oh, but this is expecting a list of dictionaries. Hmm. Okay, so this is expecting a list of, like it's passing in a list of dictionaries and then call model should then maybe when it's formatting the messages. Um, um, if else if message dot role equal, oh, yeah, equal to environment. This is the tool result bit. What we want is formatted messages are append. We could just YAML dump, oh, JSON dump it for now. So dump this into a string. Oh, and we don't need this question. Um, so the list of dictionaries, or we could just kind of a standard form would be there's a list of results. Results don't matter particularly in which form they pass back. Oh, but it needs to be no. So we need to do actually what we need to do is for yeah here and then pass in the dictionary. Next the content. Oh wait, can it be? No, it's a list of dictionaries. So if chat message is a list of dictionaries, oh, message type is tool result. Then what it does is so we need to either message type is tool result or tool call. So we need to actually add this. And then if it is, and for each part of the message, I see it's converted into this form. Name and content are required. Okay, we'll see if we have name and content in there. But it was a list, right? Like that's fine. So all we need is for yeah, and then tool result. Tool result is the form. Then we don't need any of this. Now it's if it's a list. Okay, then now we need to see how we're formatting this. Content. Uh, this is form that people. Firstly, this is like weird anyway. Name is tool called name. So there's name and content. Let's just go. Which that needs. This is becoming more work than we were hoping for. By trying to reuse the Gemini, like the existing Gemini send message model function. um, okay, this form isn't particularly relevant anyway. So let's try again. I think that the problem is with this. Remove that because it seems like it's not particularly required in that form. Otherwise, we put it back as like in the form that like in the form of tool call.name if that is required, like the key value pair with tool call containing the name of the tool that's being called. So I don't see it when I do the search. And just update it to pass the tool call object. But it seemed like it's not required, so we may not need to pass it in at all. Oh man. Oh, I see. Need the specific. I mean, only Gemini is using this in this form. I mean, technically, then we don't even need to call. Yeah, and then this may work. Well, there should be some priorities. Things from the action results being pulled out, 3 things. And then one other thing, the content being updated. Because the content is populated by the environment. So this is like an action result, like it's first pre-populated with what the agent wanted to do. And then the content is later on populated by the environment after it's taken a step. So if the model is like, hey, open the browser, the environment is the one which knows whether its suggestions to open the browser, like that instruction, that tool call actually succeeded or not. And so then that populates this by calling add action results in the operator iteration loop, the top level loop. So first the agent just says like, hey, this is what I want to call. And these are some existing things that are pre-populated. And the environment does a step. It succeeds or fails. The content portion is populated afterwards with the results of taking that step. Okay, so we've reached here. Now Why did we reach here? Thought we had populated the message result, the tool result with. Okay, so this is the content. Oh, oops. And but additional keyword args are not set because I think here, what's it called? Name. Yeah, this doesn't. Oh, this is by the user. Add action results just converts that into a user call. I'm not sure, but basically, like when we add these, we don't add that tool result. And then when we check this, why is this so much? So much highlighting. Okay, so the user property, like the user can return a result, but they don't have to return a result. So if we just change the message of role equal to user, that's not gonna work. We can where's the add action result called? It's called in the init sequence. Said after the environment step is done. I'm wondering why it's not called environment here. Let's check the other folks. Yeah, they do it. Okay, this may just be a problem with this. Okay, so it should be an environment step. And then if it's an environment step, then we add the tools. Also, this is maybe better. Found a bug in the way the add action result was happening. Let's see if there's anything else. We should be looking at from the rest. Okay, so no results. We return this as is. If there are results in the environment steps, can we create these action results? If there are environment steps here as well, we use that to get the result content, populate that, and then populate this. Maybe we should put a breakpoint here as well. Maybe here and maybe here. Just to see what's up when that happens. What we want is in the chat message model, tool result being set and the additional keyword arguments. Okay, so here we are. The tool responses contains tool result, name, content. That's fine. And then the role. So the messages right now contain the user's original message, the assistant's, the AI's tool call, and then this is the tool result, which is fine. Then we ideally hit this point with the message being the tool result. Okay, so then this should then populate it with type tool result and additional keyword arg set to like a dictionary with message type tool result in it. And then I'd leave it. Oh, guess we completed that sequence. Oh yeah, nice. So now, okay, so now we are doing the loop. So I can remove these breakpoints for our purposes now. Okay, so at least we're able to like loop here at 2 or 45 minutes. And then there's one error here around what happened here. API chat operator environment act, and then if response text. It may not be a tool call. Uh, if it's not a tool call, how do we recognize that? Oh, and response.raw content. No, because raw content we're still setting to okay, this is a little unclean, but an unclean way to recognize this. Or we're just being like if the string contains starts with the like well, maybe it's unclean, but if it starts with or ends with square bracket, then that means it's a list, and so we assume it's a tool call. Yeah, but anyway, we're seeing the model try. Like try use a terminal much more aggressively than actually we haven't checked. Are we passing it even the vision like the and let's check that. Like are we passing it screenshots and how these data may not be passing it screenshots. Okay, okay. Let me just remove this for now. Right, so like this is the part where we're using this to decide. Oh, wait, we didn't put a breakpoint here. Messages. Screenshot. The model doesn't even see the screenshot. We should just pass in this initial screenshot, I think. Right, user query here, and then we add, oops. Um, oh yeah, current in state. And current screenshot from ENB. Oh yeah, we're in a debug repo, but no, we want this to be a list, right? So wait, how do we do it? We do it for OpenAI, I think. I mean, for all models, we will do something like this, but what I want to know is in the act part, we we just add this and then I think we don't like give it in the first instruction, but then yeah, here we at the end always add a screenshot or something. And we can structured message, pass it images, get back the this is what we should do. Um oh yeah, I can pass query in. Yeah, message good query and then image is equal to this standard query and then this content can then go in to okay. Content initial environment screenshot. We passing at least at the start to the model. Um, the screenshot of the computer state. I'm wondering if we should add it um after every action the model takes as well. Just add action results here. But we can at least start with this and see what's up. Okay. So we started looping, at least there are some errors which we hopefully resolve, but at least we're looping now. Yeah, let's look at the messages. This agent message contains. Oh, wait, why does not contain? It does this never get hit? Um, Interesting. Let me restart this. I'm wondering where the message is getting. Oh, during. Wait, this calls this, which calls query, maybe getting. Yeah. Okay, so it's getting populated here. Um, so that sequence not getting hit. So what we want is central lamp. This, I think we should just add. Is what this assistant wanted to do. Then we figure out what action it mapped to. We created this, the add action result. Maybe an add action result, we not only put in screenshot A64. Actually, what type is this? I don't think it's WebP. Yeah, all of them were expecting. Yeah. Okay, great. A PNG instead. So we start and oh, we don't need to add this. Oops. And we don't add this. Yeah. Messages not set. Just construct the message. And then we put that in. Oh, and append it, not initialize it with this. And then we want to do it Yeah, maybe for the um the agent messages added. Just as a reference, but like because like some things are not about uh don't result in updates to these the screenshot, like the state of the computer. Well, they update the state of the computer, but not what you see visually. So like a terminal command or some such runs not on screen, unfortunate. Like right now, we don't in the train of thought when you see the model using a terminal, it's calling in to a separate terminal, which doesn't like not a GUI terminal, but like a sub process, and so that makes it not visible on screen. Unfortunately, we need to fix that bit, but for right now, it's not visible. Um, so the screenshot shouldn't be like at the top because the model could get confused about that, but its response should be like the final thing, the actual response by the environment. Um, this is fine. It requires I should stage some of the stuff. I think it just requires it, but then yeah, if not is none or empty, then it adds it, so it's fine. Pass in an empty thing. We just need to pass it the image. Maybe we can tell it, or maybe we don't want it to. Okay, well, we're not gonna worry about that right now. Whether we should like inform the model in this thing of like state of the computer screen. Um, right. So like right now we're in the sequence. We're almost hitting the TR mark. We're right now in the sequence where we've gotten the Gemini model um, looping, and we're trying to somewhat improve its performance on like just be able to see the screenshots and stuff because the Gemini 2.5 Flash at least seeing isn't choosing to take screenshots, and then um it's trying to use the terminal to do a bunch of things because it's more comfortable with the terminal, it feels like. But we're hoping that if we pass in, all right, I want to see this. If we pass in screenshots of the oh, this is fine for the first message, we don't populate the screenshot, but we want to, after each action, um, populate the screen, like the state of the screen, the computer screen that Khoj is using. Okay, we hit this part and we have image URL, which is good. Maybe we keep breakpoint here and remove this breakpoint actually. Now we have these formatted messages with the image blob in there, and then the function response. Um, well, actually, I'm not sure whether that's the way to do it. You may need a function. Um, yeah, let me think about that. Content parts can have multiple things in it with a function response containing, let's see what this function response. Um, let's just see if it runs. Does it complain? didn't complain. I'm not sure whether like putting like after a function call, doing a function response is expected. Okay, try to click left. Oh, it sees Firefox already open. That's good. So let's just let it run. Once we share the screenshot, it's oh, was it able to? Try to type in weather in Seattle, so it's doing something. So the train of thought should be improved a bit just for us to be able to see this thing, but the model is now scrolling and things, and is able to see um see the computer, scroll, type. There is some it's unclear whether it's grounded, like visually grounded well enough, or we need it to tell it in a specific form to do stuff. It's back to the terminal. But at least we've gotten it to start, like it typed in Heather in Seattle or some such, and then um, it's saying a bunch of other things about how it's getting annoyed about trying to use this thing. Okay, so it opened. Wait, where did it click? Yeah, it's clicking at things. I feel like. I'm just trying to figure out whether it's like grounded now that it's clicking on the right thing that it's wanting to, or if it's losing its plot. Um, okay, so this is the part where it's like using a terminal. So we're not seeing the actual. Um, it's trying to like remove, kill Firefox somehow. It thinks it's not like working for it. Um, but yeah, like I think we like close the session down at this point of time. What we're at least, oh, we can, no, we could see it like this. I should we can like see the model at least being able to interact with um oh, it opened Firefox. Um yeah, so it's doing these clicks and stuff which feel like it's clicking at the right place. Um yeah, let's go for a while so you guys can see what's up here. But my main part is like we gotten the Gemini model to function as monolithic operator agents for Khoj. Um in that we are able to interact with the model in Khoj and then give it screenshots, ask it for actions. It does actions which we apply on the environment, and then we give it back the current state of the environment. Okay, great. So it's searching the weather, which is awesome given that we've not done any prompt tuning. Um, that I'm not exactly sure why it struggled to work with the initial browser, but it's seeming like at least it's able to click um, enough times that it gets the weather, right? Um, and I'm not sure why these messages seem to lag. Okay, type weather in Seattle, press enter. Oh, I see. I think it got so it got to the weather in Seattle bit. There's some error here, which we can fix up, which I think is at the end sequence when the model wants to respond back. We have a null ref because we put tool calls in here, but then we expect tool calls to be present. So we should just define tool calls up here and then start again. But the part is like we got the model, like we fixed up the loop, the operator agent loop to be able to use more Gemini. We are able to interact with the Gemini model in the operator loop, and then it seems like it's able to um, use the browser and stuff. One difference that we had to do, apart from just fixing up the interaction loop, is to pass in screenshots to the model after each action. Again, not sure if we need to necessarily pass it after each action or during just the first message, we should pass that screenshot in to like give enough context to the model of being like, hey, you have an actual computer that you can see, and use screenshot tools. Because for the Claude models, we don't tell it, like we don't first pass it the screenshots directly, and then second, we don't, like once we told it you're using a computer, it knows when it wants to take a screenshot. And while there may be some optimizations around should we pass the screenshots all the time irrespective or not, the trade-off being it slows the operator loop down because now it's processing an image every time. And second, it becomes costlier because every time again, an image is being processed. So some trade-offs, but with at least the Claude models, we can kind of make it do a bunch of things without needing to explicitly pass screenshots every time, irrespective of whether the model asked for it or not. So we've gotten the Gemini model working and the grounding working somewhat. Oh, before this, let me not this. Reset the state of the Khoj computer. So that we have none of this. We start from clean screen. But the exciting bit is if we can use Gemini models that like 2.5 Pro is pretty good. So I wanted to kind of test out how. Right now we're testing with 2.5 Flash just to initially we were like, oh, okay, it's clicked the globe icon. How does it see the web? Um, I think it had the interrupted loop in it, but let's start a new one and see. Oh, again, it'll like, and then I don't know why it didn't generate the panel response. Oh, did the summary fail? Or maybe we don't summarize at the end. Uh, and now it's seeming to match what the train of thought is. showing. Right. I think it's having problems. So it's trying to click like this red blob is where it's trying to click. Um, when it's saying it wants to like it's doing a click. We tell it to like use Dr. Go just because Google blocks the like usually goes into recapture mode. Yeah, so I think there's some problem with the model being clicking the right place always, which is why you're seeing a bunch of things open up. But for folks who kind of join it later, like we do see these models seem like they should be able to click. Not sure whether they can click very precisely, but at least just like Google Colab seems to suggest that it can do some amount of grounded clicking rate. Um, and just like, yeah, so, and we should try with like 2.5 Pro as well, just to see where it gets us to. But for now, while we'll experiment with those, for now we can like shut this session down with the results of this session being just like we got Gemini models to be used as an operator agent, so we can try out how well they do computer use already, and if not, then to figure out some other mechanisms, or just kind of chuck Gemini for now and just use Claude or Anthropic. But I feel like it's close enough. Like you can see it, like it's gone to weather.com. I'm not exactly tracking how it's doing it, but it's gone to weather.com. So it's able to figure it out eventually, but it's not the most efficient at it. Yeah, it's not the most efficient at it, at least 2.5 Flash. Maybe we should try with 2.5 Pro as well. But it's not at least feeling like without the prompting, because we've not done any specific prompt tuning. But I think even with the prompt tuning, it may not be necessarily that great, or maybe the prompts get it into the right mindset. But right now, it's stumbling its way through, not always able to get it in one go. And wait, let's just do two example runs, right? One with Gemini 2.5 Pro instead. Just to see if 2.5 Pro's doing it better. The other we can do is, just want to see. There's documentation about this. It's just a generic page. I don't think they've added any computer use or operator. Maybe it's an image understanding or something. Object detection. Oh, right. The other thing could be the coordinate relative to image dimension scales to 0 to 1000. Hmm. Oh, what if it's just this? Maybe we'll spend a little bit more time just to kind of get this. Yeah, maybe we'll just spend a little bit more time. Let's see what's up. JSON load, bounding box. Just passing out the response. Geez, I'm not sure why they're not using tool calling. Sure, maybe just to simplify, maybe the model's not been trained that well on that. And then all they're doing is whatever the point is being scaled, divided by 1,000 and scaled up to the model's height and width. Interesting. So two things to do. One is I think all these click actions are X, Y-ish, X, Y, X, Y, X, Y. Right, so let's try and just turn X, Y, if there are X, Y keys, scale to the, yeah, image size, great. We have the current screenshot as well. So we can use that. What we'll do here is for each tool call, we will normalize X, Y coordinates to image dimensions. Brilliant. It's done mostly what we want. First, we don't want to make them integers or anything. At least not right now. Great. I'll just pass it as is. So that's one thing, and then we have to tell the model wherever the system instruction is. System right here. Wait, what was the instruction that they were giving it? We're not doing bounding boxes, we're just doing points, but the points are in YX format. Anyway, let's points. Doing mouse action point click. Point should be normalized to 0 to 1,000. Um, okay, so those two things we did. One is when the tool calls are defined, when the tools are called in the act part of the model, if they contain, the tool inputs contain X and Y, we rescale them to the size of the image input. And then second, we um, we rescale them to the size of the image input, and we tell the model, similar to how they're saying it in this Google Colab, and seem to be suggesting stuff like this somewhere here as well, that the model should like the normalized to 0 to 1,000. That's not right. An operator, whether in Boston. Are we using 2.5 Pro? I forgot. But we were gonna try and we're using 2.5 Pro, and we've told it this. Not sure if this can help or not. It may, and that'd be great. But based on just like again, like based on how they're talking about these things, they seem Gemini models seem to be potentially capable of computer use, but it's not very clear why they're taking forever. We should just use the 2.5 Pro, 2.5 Flash for now. But my point was just like based on how they're talking about like this object detection, segmentation, and then there's somewhere mentioned, the 2.5 models are further trained to support enhanced segmentation in addition to object detection. It feels like they're trying to move towards or have moved towards computer use. Maybe they're not happy enough with the state of it, or they don't want to talk. I don't know, like why they wouldn't want to talk about it, but maybe they don't want to talk about it right now. Wait, it can't be taking this long, right? Let's just maybe go back to Flash. Did we restart the server? I think we did. Just recharge again. Go back to Flash actually, just to be faster around doing this thing, because we know how Flash was clicking. It felt like it was almost clicking at the right spots, but not quite. It would stumble through it, but would eventually start to get to the kind of points that it needed to. Okay, we're at 3.5 hours almost. Hopefully we're sure with this. We were going to end it, but then I thought, let me look at the documentation one more time. Whether in whatever Boston, and then we stumbled on the like normalization part. So we just want to test that out with these Gemini models to see if that improves. Oh, and I should just not stage any of this stuff. Right, where were we here? What have we done? Not sure if we're using this part we have updated, and this part we should totally put up. all we're doing here is like this is the entry point for the operator sequence, and we're adding support for the Gemini models. So this is part where we add if Gemini model, then instantiate the Gemini operator agent. And the Gemini operator agent is defined here, which we did right now with Cline. I feel like what's happened is, oh, is the computer dead somehow? Because not even this flash is taking a while. Let me kill it and then start it again. So this is Khoj's computer, and then we're just trying to, as I was initially like 2.5 Pro being slow, like it does sometimes. So we started its computer. We want to see if the computer comes up. We're just connecting to it with PNC, and it is almost up. The wallpaper should come up at some point. But it's a normal computer. Let me show you. The wallpaper's up, and this is working. It's down, like a connection down to it, and then try again. Hopefully it starts up fine now. But we're not sure why it didn't start up the first time around. So, well, if it stops working, I'm not gonna like try and debug this thing. We'll just shut this ice stream down for now. Maybe I'm just getting tired, and oh no, it's working. Okay, great. We are talking to Gemini 2.5 Flash. Let's see. Okay, so try to open the browser. Okay, it's, you can see it's the red dot is where it's clicking at. It's closer, but not quite. Yeah, so you could, it's kind of missing it by a bit. Is it worse than before? Okay, it hit the application menu, but I'm guessing it'll miss the open. It's missing it by a bit. I don't know whether I should get into tuning. Tuning where the model's hitting stuff. I want to say the width is a little off. It opened the browser and but if I wait, no, I should scale this down fine and then add. Just add or multiply, I'm not sure. Is it like scaling linearly or I felt like I was just hitting it off by a little bit. So let me just do that. Okay, this is getting hackier by the moment, but I should scale it, I think. Otherwise it'll always hit it a little off. Height was fine. Maybe it is. Of course, this would not work for. And maybe we should try with. Felt like it maybe degraded the model's performance, so it did open its browser up eventually. Okay, unclear if that helped and by how much. Um, I think we can leave the debugging sequence for now. I'm just getting like, I think I'll keep doing this once we shut down the live stream, but I think this is a long enough session. Not sure if folks want to continue seeing a 3.5 hour long session. I guess if folks have comments, they can leave it in the chat as they want to continue with this. Me debugging and trying to like improve the Gemini operators computer use capabilities. If no comments, we will shut it down in 5 minutes for sure. And then maybe yeah, and like before the end, and show how normal Anthropic, like the Claude model does it, and or for like a more sizable task. I'm not sure whether the interrupts again work because they broke, as I said earlier, when the WebSockets were changed, but I did some edits that allow the like that should help with the interrupts. I have not tried it, but with interrupts, it is when it's useful, when it's running longer, kind of, it's doing longer tasks. You want tell it things in the middle, either to change its trajectories or move on to a next step. Not just like it's not doing the work you want it to, more like maybe you thought of something, maybe you forgot to tell it something, maybe now whatever you and Khoj have looked at while it's thinking in its train of thought here and showing where it's at, you could be like, okay, now why don't we try some, next thing. Let's see. Okay. That was it's getting frustrated with the whole clicking and not hitting the right spot. Okay, so this is not like my scaling thing is not clearly working either. Where were we here? Like may have degraded this further. So let me revert that part. Maybe we revert this scaling completely, but I'll keep it for now. And actually, let me put a breakpoint here just to verify whether we're even hitting the scaling. Part. Oh, and then maybe take two need to be in int form. Yeah, so let me just start this up again, try one more run with this 2.5 Pro and then Claude. And we'll not try and do any more edits to the code for now, and then close the close the live stream down, then I can debug in peace. Okay, let's try again. Now we're not doing anything to the model. We're not doing too hacky things. The computer started. Okay, so there was XR coordinates. Um, and both of these are here. Interesting. Oh, this is actually useful. So change the Y downwards. I think it didn't change the X. Okay, so 247, 603. Oh, it did change the X now. And the Y. So the Y is changing by quite a bit. Yeah, so to click the search bar. Uh, okay, so it's still having problems hitting the buttons. I'll just show how normal existing Claude works, just to ground people in what right now we can do with this operator mode. So I'll ask Khoj this question. Um, and then see like how Khoj goes about when it's at least with a grounded model, like when we know a model that works, how it does it. Um, and then we'll try out whether the interrupt works or not, but at least we get a sense of um, how you can use the operator mode to get more work done. So you can see like in the first click, it got the right onto the address bar on like the Gemini 2.5 Flash model, and then it's going to Khoj, the Khoj repo. And the interesting, like the interaction sequence, which is nice, is where Khoj is doing its thing, but we can see what it's doing. So we are also like in this part, I don't know what all issues are there, like in my memory, but there are issues open on the Khoj repo, so we could both look at it, and then I can kind of like it's a like collaborative workflow where I can see what Khoj is looking at, and then we can be like, hey, why don't we pick up this item, or why don't you do this other thing, right? I'm gonna let it do its thing for a bit, and then we'll try and jump in and see if it's uh, getting our messages. And here, yeah, like you can see it's choosing to do screenshots when it wants rather than us giving it a screenshot every time. Try to the number 1183. So I look into autocomplete suggestion. Okay, so we send it a message, not sure if it went through. Okay, it's gone in here. There are a bunch of messages here. We want to add the interrupt message. This is good that it's hit here. Just want to go here. And then see if it continues. Okay, so it seems to have injected it in at the right place. Yeah. Okay, this is awesome. So we've gotten the interrupt thing working. This was before the live stream started, but I wanted it to be interruptible. And WebSockets, one of the reasons we had done the WebSockets bit was to allow a cleaner experience. But you can see here the user message is there with what I said, injected into the operator's reasoning trajectory till now. The previous, like we did allow it before, it was a lot more jank. This should ideally be better. But you can see like it chose the right issue. It remembered it from its previous traversal, scrolling through the issues because it wasn't in its current screenshot. Okay, so it's opened this issue. I had made this issue as a good first issue. This is just an example of what kind of make Khoj do again, but the operator mode. But now it's like this is how the like train is looking. There is some issue with the way we are like formatting the messages on the web app. Like it's rewriting the original message, but the idea is the original. If we fix once we fix that bug, the original message there, Khoj does a bunch of stuff. You say something more, it continues doing other things in this like video form, right? So right now it's kind of reading the issue. I think it's done with this operator run. So the research agent asked it to do a thing, which was like find a good issue to work on. It did, and now it's given it back to like it's told the model. There may have been some issue with the way back and forth happened. Where the research agent's telling it to do something which is already done, like it's uh, um, So the research agent should maybe be also told about the user message that got injected in the operator run. Unclear why it didn't realize that. Maybe it already has it, maybe it doesn't. But what we're doing is here is telling the model things while it's working. We can send it interrupt messages, and the research agent also is contributing. So the research agent is telling the operator agent, do this thing when it comes back, and then tells it the next step to do. And so with that, you could be like, hey, find issues, like then start working on the issues. So I've done some runs where I'll make Khoj work on an issue on its computer. It's not um, Khoj, being able to run Khoj with computer isn't, I haven't solved that yet. Once I have that figured out, either on its own computer or some other computer, once I solve it, then we can um, make Khoj. We can make Khoj work on its own issues, fix them, reproduce them. That's one of the things that I want Khoj to be able to do in operator mode, just to be able to maintain the Khoj project, like help us maintain the Khoj project. So this is one of the kind of samples that we've been trying with Khoj. But yeah, like as you can see, like we can make it do a bunch of things. I'm not sure where it's at with what I was telling it, but you can, yeah, like you can make it. With at least Anthropic models, be able to work in a terminal on a browser environment and in use a file system to create projects, look through issues. Like, it'd be cool to remember like which specific issues I had Khoj work on, but there were some issues where it helped me debug some stuff. So in its terminal, it like git cloned Khoj. Oh, there was some fine tuning, model fine tuning runs. So that's below like the Khoj agent layer, but below that layer, we were making Khoj. Um, write a project for fine tuning um, vision models into grounding models, like vision grounded models. And so it cloned the repo that we were going to like use, and then wrote a bunch of training scripts for training a separate model that the original um, vision training thing. I think it's by Hugging Face. I don't remember its name. Um, that original framework didn't by default support that. So I just told it like, hey, for this model, I want to um, train it using this framework. And then it was able to create the scripts. Of course, we can't run it on the local thing, and I haven't run it yet to verify where all it's failing, but we could kind of do a back and forth and get to that. So it's pretty fun. If you folks are download Khoj, like git clone it, and then it, you should be able to see it. You should be able to play with it, see where it goes, and see where you can like where you're hitting roadblocks, contribute to it by looking maybe at this like live code or some of the other sessions where we've debugged and try to figure out why Khoj is able to do some things, not able to do some things, if it needs other tools, or if there's some issue with um, the way we're showing the messages and stuff like that, right? Cool. So I think we're at the end of the sequence. We're almost hitting 4 hours now. It's quite fun to do this live coding. It was a decent amount of work to prepare for these things, but it was quite fun to work on projects. Personally, for me, in this format, we'll not, of course, be doing this every day, but I plan to do one live code session at least. Like we'll kind of scale this down to once a week. On the weekend we'll do it going forward, and then if again that's not working out, or it's too taxing, or if it's too little, we can ramp it up and down as we go. But that'll allow folks to on the weekend, hopefully at like a standard time, we can have once a week, live coding for not this long, maybe an hour, maybe max two. Um, let's see, but kind of follow along on what's happening in Khoj, but also like in one of the ideas is to encourage folks to contribute um, and understand the direction Khoj is going in, but also understand like where open source AI agents are going towards. So if they're working on their own projects or they want to contribute to Khoj, they have a better idea to be able to build better open source tools um, that give people like control and access to their own personal AIs. That's the hope. That's why we're doing it in open source. That's why we want more folks to be building cutting edge um, AIs, but in the open, AI systems in the open. And so this live coding sessions meant to encourage folks to do that either by contributing to Code or to work on their own projects. Hopefully folks got some stuff out from the 1 week of live coding that we did, where we built better document retrieval tools, tuned them, built a voice mode, built visual chart, um, visual story mode, added MCP support, and then last thing today we did, which was added a new provider, a Gemini-based provider for operating a computer with Khoj. So hope folks got like a bunch of different features that can be added to Khoj or added to AI agents. How we think about it can take something from it and or contribute to Khoj, which we'd love, of course. Hope folks enjoyed it. Thanks a lot. See you maybe next week.